Hello and welcome to Math with Mrs. Becker. Today we are looking at pre-calculus and we are finishing up Chapter 1, Section 4. The first thing that we want to start off with is really looking at what's called the point-slope form of an equation. Now, in order to write an equation in point-slope form, you need exactly what it says. You need to know a point, so I'm going to call that x1, y1, and you need to know the slope, which is m. So here is the point-slope form. It's the variable y minus the y value from the ordered pair equals your slope, which is m. Then you start a parenthesis, and it's the variable x minus the x from the ordered pair. So y minus y sub 1. Y sub 1 is a y value from an ordered pair equals m. M is your slope. In parentheses, x minus the x value from your ordered pair. Now, often, this is a transition equation. What this allows you to do is figure out an equation in slope-intercept form using this form. And that's what we're going to go ahead and do today, okay? It says, sketch the graph and find the equation of the line that passes through the point 1, -6 with a slope of 2. Okay, so if I'm going to go ahead and graph this line. In order to find a line on a graph, you only need 2 points, okay? So 2 points create a line. They gave us the first point. I go to the right one, go down 1, 2, 3, 4, 5, 6. So there is my first point. Now, in order to find the second point, because you only need 2, my slope is 2. Remember, slope is rise over run, okay? The top number is positive, so I'm going up. The bottom number, because it was a whole number, I just went ahead and put a 1 underneath it. So I go up 2 to the right 1. So starting from 1, -6, up 2 to the right 1. As soon as you have 2 points, that's enough to form a line and you're done. Okay, so we sketched the graph. Now, write the equation in slope-intercept form. So we have a point and we have a slope. So it's y minus the y value from the ordered pair, that's a -6, equals m. M is the slope. X minus the x value from the ordered pair. So first thing I notice here, I am minusing a negative. If you minus a negative, make sure that you change that to plus. Distribute a 2. So y plus 6 equals 2 times x is 2x minus 2 times 1 is 2. Last step, minus 6. So y equals 2x minus 8. That is the equation. Again, they wanted the equation in slope-intercept form. Y equals mx plus b. In order to do that, we needed to use point-slope form because that's what we knew. We knew a point, we knew a slope. So that's what I meant by this is a transition equation. If you know information, you can fill it into here, and then you go ahead and you simplify it to y equals mx plus b. Let's look at another one, okay? Sketch the graph and find the equation if you know a point and a slope. So go ahead and draw your coordinate plane. My point this time, I go to the left 2, up 1, 2, 3, 4, 5. So there is my point. Now my slope is -3. That's the same thing as -3 over 1. My slope is negative, so I go down. 1 is the number underneath because, again, I had an integer, so I could go ahead and turn it into a fraction by putting a 1 underneath. Your denominator is always how much you go to the right. So starting at -2, 5, I go down 1, 2, 3, go to the right 1. 2 points define a line. So go ahead and connect those. I put the arrows at the end to indicate that that line continues forever and ever in both directions. So that's the first part. Can you graph? Now, can we find an equation in slope-intercept form? Y equals mx plus b. To do that, we need to use our point-slope form. So it's y minus the y value from the ordered pair equals m. M is our slope. X minus the x value from the ordered pair. So again, I notice that within this problem, I am minusing a negative. If you minus a negative, you change it to a plus. To turn it into slope-intercept form, cancel the parentheses by distributing. So y minus 5 equals negative 3 times x, negative 3x. Negative 3 times 2 is negative 6. If I add 5 to each side, y equals negative 3x. If I had negative 6 and I add 5 more, now I'm at a negative 1 and we are done. Okay, so that's the first idea. Can you take a point and a slope, graph it on a coordinate plane, use the point-slope form of the equation as a transition so you can write an equation in slope-intercept form? Okay, here is a real-life scenario. An office buys a new computer system for $7,000. 5 years later, its value is $800. Assume that the system depreciates in a linear fashion. Okay, so that means the value goes down the exact same amount every year. Write the equation in slope-intercept form. Again, that's y equals mx plus b. That represents the values as a function of years. Okay, so we're going to go ahead and it's year, or how old the computer is, and the price or the value. Okay, so if I go ahead and do this, when the computer system was new, so its age was 0, it hadn't been used at all, the value was $7,000. Then when its age was 5 years later, its value was $800. Okay, so being able to take a real life situation, turn that into ordered pairs. Now, if I want an equation, the first thing we need to do is identify the slope. Remember, the slope is the second y, so 800, minus the first y, 7,000, over the second x, 5, minus the first x, 0. 800 minus 7,000 is negative 6,200, over 5 minus 0 is 5. Negative 6,200 divided by 5 is negative 1,240. So that's your slope. What this tells us is how much the value of the computer system drops every year. Okay? They want an equation. We haven't found an equation yet. We took the information, created ordered pairs, used our two ordered pairs to find slope. If I want an equation in y equals mx plus b form, I need an ordered pair and I need a slope. I have two ordered pairs. Cool thing here is you can pick whichever one you want and you'll end up with the same solution. So be nice to yourself. Pick the numbers or the ordered pair that have like zeros and ones, things that you can calculate pretty quickly in your head. So I'm going to choose 0, 7,000. So it's y minus 7,000 equals m, negative 1240, x minus 0. If I distribute, y minus 7,000 equals negative 1240 times x is negative 1240x. Negative 1240 times 0 is 0. If I add 7,000 to each side, here's my equation. Y is alone. Y is negative 1240x plus 7,000. Now here, I can use this equation to figure out the value of the computer system for any age. X is how old is the computer system. So this says find the value of the computer system 2 years after it was purchased. So that means x equals 2. So y equals, y is the value, negative 1240, x is a 2 because we're looking at 2 years, plus 7,000. So if I go ahead and I calculate that, I have negative 1240 times 2 plus 7,000. The value would be 4,520. Okay, if I am graphing the function, remember when you are graphing in y equals mx plus b form, whatever comes after the x, that is your y-intercept. That's where you're starting. So in our case, we're starting up 7,000. So I'm going to go by thousands. So 1,000, 2,000, 3,000, 4,000, 5,000, 6,000. 7,000. Good thing I didn't go up one more line. I wouldn't have had room. So if I'm graphing, this is 7,000. Now this is the years. 1, 2, 3, 4, 5, 6. Okay, so my first point is up 7,000 because it's a plus. Now this is my slope. I go down 1,025 over 1. Down 1,025 over 2. So I have a couple points, enough where I can connect and see that the value is dropping. So as the computer system gets older, the value of it is going downwards. So we graph the function. Now, find how many years before the system is worthless. That means that it's equal to 0. Well, y is the value. So if I say y is equal to 0, negative 1240x plus 7,000. By changing y to 0, now I can just go ahead and solve for x. X would tell me the age at which the computer system would have a value of 0. So step 1, minus 7,000 to the other side. Negative 1240x. Now divide both sides by negative 1240. So if I go ahead and I do this, negative divided by negative is going to be positive. So it's going to be 7,000 divided by 1240. It's approximately 5.645 years. So a little over 5.5 years, that computer system is now worth nothing. Okay, so real life examples, why do we need to know how to do linear equations? Let's look at the backside. Now, not all lines are going to be diagonal in nature. It's okay to have lines that are vertical or horizontal, and that's what we're looking at next. When a line has a slope of 0, it is called a horizontal line. Remember, horizontal lines run side to side, okay? The equation of a horizontal line can be written y equals b, okay? So my slope is 0. So where the m is, it would be 0. 0 times x is 0. So what you'd have remaining is y equals b. This horizontal line, it cuts the y-axis, okay? So if the variable is y, it cuts through the y-axis, okay? A vertical line has a slope that is undefined. And what happens there is when you are doing your slope formula, you end up with a 0 on the bottom. In mathematics, you can never divide by a 0. So if you have a 0 on the bottom of a fraction, that is said to be undefined. The equation of a vertical line can be written as x equals c, and c is a constant. So again, vertical lines run up and down. Notice that in the equation, it is x equals. So those lines cut the x-axis. Okay, this says describe and sketch the graph of the equation y equals 3. If it's y equals, it's horizontal. It cuts through the y-axis. So that's enough for describing. Y equals, it's going to be horizontal. It cuts through the y. Where does it cut through the y? At 3. Y goes up and down. This is a positive 3, so we have a horizontal line that cuts through the y-axis 3 units up. That's it. Describe and sketch the graph of the equation x equals 2. X equals is a vertical line. It cuts through the x-axis. Remember, the x-axis runs side to side. So if I am having a line that cuts through the x-axis at 2, I need to go to the right 2, and that's where the line would end up. Okay, last idea of the day, parallel and perpendicular lines. Parallel lines, by definition, they never touch. Their slopes are equal. That's why they never touch. They rise and run or fall and run at the exact same rate, so they will never cross. Perpendicular lines cross or intersect, and where they cross, it creates a perfect 90-degree angle. In order to create that 90-degree angle, their slopes have to be as different as you possibly can imagine. They are opposite. Now remember, opposite means one has to be positive, one has to be negative. The other thing is they are reciprocals. Reciprocals, that occurs where you flip your fraction. So like the reciprocal of 2/3 is 3/2. Two non-vertical lines are perpendicular when the product of their slopes equals -1. Now that is a property that we actually looked at in Algebra 2. It's called the multiplicative inverse property. And what that states is when you multiply reciprocals, you get a 1. In this case, it's a -1 because we're not only looking at reciprocals, we're looking at opposite reciprocals. Okay, last idea for the day. Can you figure out the equation of a line that would be parallel or perpendicular to another line if you're given a point? Okay, so given the line M, whose equation is 3x minus 2y plus 6 equals 0. This you need to use to find the slope. So what I want to do first is get y all by itself. So if I have 3x minus 2y plus 6 equals 0, I can add the y to the other side. Y can be on the right or the left. By putting it to this side, it's going to be positive. So 3x plus 6 equals positive 2y because it's negative here. So in order to move it, I had to add it. Now, in order to get y all by itself, I need to divide everything by 2. Keep this as a fraction because this means up 3, right 2, up 3, right 2. Plus 6/2 is 3. So these two things are the same equation. The reason why this helps me is because now I can see that m is 3/2. We want an equation in slope-intercept form. Remember, that's y equals mx plus b. We want our line parallel to this and through the point, okay? Parallel means that the lines have to have the same slope. So if this slope is 3/2, our slope has to be 3/2. We are going through the point to -1. So again, I just use this to figure out what my slope would be. Because it's parallel, I keep it the same. Now it's y minus the y value from the ordered pair, that's a -1, equals m, 3/2, x minus the x value from the ordered pair. Minus a negative becomes a plus. Distribute to cancel parentheses. So y plus 1 equals 3/2 x minus. Now when you picture this, you're taking 3/2 times 2. Remember, anytime you multiply by a denominator, they would cross cancel. So what I'd have left here is a 3. Minus 1 to each side. So y equals 3/2 x minus 4. If you graphed these two lines, they would be parallel to one another. They would not intersect. This line would go through the point to -1. Okay, what if they wanted it perpendicular? Well, here's the equation of the line. The slope was 3/2. If you want it perpendicular, your slope needs to be the opposite and the reciprocal. This slope is positive, so ours would have to be negative. This is 3/2, so ours would have to be 2/3. Again, they want it through the point to -1. So y minus a -1 equals m, -2/3, x minus the x value from the ordered pair. Minus a negative, this becomes a +1. Go ahead and distribute. So it's -2/3 x, negative times a negative is a positive. Remember, when you multiply fractions, it's top times top, bottom times bottom. So this becomes 4/3. The reason it's a plus is because I had negative times a negative. Now I need to minus 1. Well, when I'm minusing here, I'm going to write my 1 as 3/3. The reason is I am subtracting from a fraction. You cannot subtract fractions unless you have a common denominator. 3/3 has the same value as 1. So I just wrote it in a fraction form that contained a common denominator. Y equals -2/3 x plus 4/3 minus 3/3 is 1/3. Done. Okay, all the different equations, there's lots and lots of forms to write the equation of a line. One of them that we really don't work with too often is called standard form, and that is ax plus by equals c. That's the form that they gave us in this previous question. Oh, actually, it wasn't even. if I minus the 6. It's where your x and your y are on one side and your numbers on the other, okay? So just as a quick review, everything we've looked at in 1.4, there are lots of forms of equations for lines. Standard form, ax plus by equals c. Slope-intercept form, y equals mx plus b. Point slope, y minus y sub 1 equals m times the quantity x minus x sub 1. If you have a horizontal line, it cuts the y-axis, so it's y equals b. Vertical lines cut the x-axis, so it's x equals c. Tomorrow is a work day. This is what the book assignment is for Chapter 1, Section 4. So again, you get the full class period to go ahead and work on the assignment. You can look at the notes from 1.4 Part 1 as well as today's, which is 1.4 Part 2. I hope you had a great time learning about slopes and lines. Talk to you soon.